For centuries, we wondered what was on the surface of Mars. But today, with a fleet of spacecraft in orbit and rovers active on the ground, we know more about Mars than any other planet beyond Earth. We've seen huge canyons that once held water, observed distant dust storms, and even found some intriguing signs of life that may once have existed there. These discoveries were all things we were actually looking for. And yet, the red planet continues to surprise us too. Recently, NASA's Perseverance Rover detected something completely unexpected, something it wasn't designed to investigate, something we'd almost lost hope of finding. That tiny crackle, like a jack cable being pulled out of a speaker, could be the first ever evidence of lightning on Mars. A phenomenon that no matter how hard we've searched, even with specially designed missions, we have never detected before. So why is it only now that we've been able to hear it? What does this mean for the red planet? And could there be implications for future manned missions? I'm Alex McCohen, and you're watching Astrom. Today we're traveling to Mars to investigate a sound so small it was almost ignored, a tiny crackle that could hold the key to how Mars's atmosphere works, how its storms form, its surface chemistry, and whether humans could one day safely walk its surface. The first lander to touch down on the Martian surface was NASA's Viking 1 in 1976, shortly followed by its sister probe, Viking 2, a few months later. These two landers provided the first close-up color images of the Martian surface we've ever seen, revealing a red-brown landscape under a dusty orange sky. Since then, we've successfully sent 8 more landers and rovers to the surface, 2 of which are still active at the time of publishing this video, NASA's Curiosity and Perseverance rovers. Between them, these remarkable robotic explorers have dramatically increased our understanding of Mars. They've shown that the planet was once covered in liquid water, and that vast reservoirs are still hidden, locked up in ice just below the surface. Our intrepid rovers have had to deal with all kinds of Martian weather, from glaring sunshine to fierce winds and raging dust storms. But one thing's long been missing: lightning. We've seen it on other planets. Voyager 1 spotted bright flashes on Jupiter when it flew past in 1979. And more recently, NASA's Juno probe captured stunning images of Jovian lightning up close. On Saturn, storms can stretch for thousands of kilometers and unleash lightning 10,000 times more powerful than Earth's. One colossal lightning storm observed in 2009 by the Cassini spacecraft raged for a full 8 months. But lightning has never been detected on our planetary neighbor Mars until now. And that discovery is a really big deal because lightning is far more than a simple weather event. On Earth, lightning plays a vital role in the chemistry of our atmosphere. It forms when ice particles collide inside storm clouds, causing them to gain or lose electrons and become positively or negatively charged. As that electrical charge keeps growing, the air between the cloud and the ground can no longer hold it back, and the electricity suddenly discharges as a lightning bolt, releasing so much energy the surrounding air is briefly heated to over 27,000 degrees C. That's hotter than the surface of the sun. The burst of energy is so intense, it can break apart nitrogen and oxygen molecules in the air, which then recombine into nitrogen oxides. These dissolve in rainwater and enter the soil where they act as natural fertilizer, helping plants to grow. As well as its role in the nitrogen cycle, lightning produces ozone, which helps shield our planet from dangerous UV rays. UV rays aren't the only solar radiation you might need shielding from. And because our sun produces a huge amount of energy, it's very dangerous to look at directly, no matter how much you might want to. And this year, you might well want to, as there will be a total solar eclipse visible from Iceland, Greenland, Russia, and Spain on the 12th of August, one of nature's most extraordinary spectacles. Even if you can't get to the path of totality, if you're in the eastern US or Canada, the UK, Europe, or northern Africa, you will still be able to spot a huge bite being taken out of the sun as the moon passes between us and our star. I can't wait to see the eclipse, and I'll be heading out to Spain myself in August. But if you want to witness this breathtaking spectacle, be it total or partial, you're going to need protection. And Vizslar's Solar Eclipse Viewing Kit gives you just that. These certified safe eclipse glasses are approved by the American Astronomical Society. And I love that they've come up with a precision photo filter that will let your phone capture the eclipse too, with no damage or distortion. And it's worth being careful out there. There are a lot of low quality knockoffs on the market that can damage both your eyesight and your camera. So it's important to stick with properly certified high quality eclipse glasses like these. So get yours today by scanning my QR code or following the link in the description below. If you use my code ASTROM2026 at checkout, you'll get 10% off your purchase. Now, back to the role of lightning on Earth. It's even possible that lightning played a role in the origin of life itself by converting atmospheric gases into vital organic molecules such as RNA and amino acids. So, in other words, lightning is far more than a flash of light in the sky. It is a critical part of Earth's natural systems. And if lightning plays an important role in atmospheric chemistry on Earth, it's likely the same will be true on Mars. Right. Well, unlike Earth, Saturn, or Jupiter, with their dense atmospheres and towering storm systems, Mars's atmosphere is incredibly thin, more than 100 times lighter than Earth's. This makes lightning, as we know it, unlikely. But storm clouds aren't the only place where lightning occurs. Here on Earth, under the right conditions, lightning can also be generated by volcanic eruptions. This incredible footage was captured by a tour guide in 2023 of Guatemala's Fuego volcano. As ash and dust particles swirl around inside the volcanic cloud, they collide, generating an electrical charge just like ice particles in a storm cloud. And if there's one thing Mars has a lot of, it's dust. Martian winds whip it up into towering dust devils up to 19-kilometer tall. Some scientists estimate that there could be as many as 145 million of them racing across the surface of the red planet on any given day. And that's not all. Giant dust storms also occur, occasionally growing so large they engulf the entire planet. The two Viking probes saw two of these global dust storms in their first year alone. Driven by seasonal heating, rising plumes of warm air create continent-sized storms. But once every 3 Mars years, about 5 and 1-2 Earth years, they combine and become large enough to cover the entire planet. Scientists aren't really sure why these year-song gaps between storms exist, but they suspect it's to do with the fact that Mars' orbit is less circular than Earth's. It means that during the southern hemisphere summer, the planet is close to the sun and therefore significantly hotter. Although wind speeds here only reach about 100 kilometers ch, about half the maximum we see here on Earth, the dust is so fine that this is enough to almost completely block out the sun. Not good for solar-powered rovers on the surface. In fact, on the 10th of June 2018, this spelled the end for the Opportunity rover, who never managed to power back on after a global storm. But whilst bad for mission planners, all that swirling dust provides the perfect conditions for lightning to occur. And for decades, scientists have been trying to detect it. The European Space Eyes Mars Express spent 5 years scanning Martian dust storms for any hint of electrical activity and found nothing. The Schiaparelli module, also sent by, was equipped with a special instrument to measure electrical activity in the Martian atmosphere, but sadly, it never got the chance. As it approached the surface in October 2016, a software malfunction caused its parachute to jettison too early and the module crashed. The high-rise camera on NASA's Mars Reconnaissance Orbiter captured this view of the crash site. But now, finally, after decades of searching, the Perseverance rover has found tantalizing evidence of lightning on the red planet. And it was a lucky break because, as I mentioned earlier, Perseverance wasn't looking for lightning at all. Its SuperCam instrument is designed to analyze Martian rocks by zapping them with a laser and analyzing the light and sound produced by the blast. But along with the sounds that bounce back from rocks, the SuperCam microphone detected a strange crackle and pop. The finding was so intriguing. A team of Mars scientists, led by Baptiste Shed from France's Institute of Research in Astrophysics and Planetology, painstakingly trolled through nearly 45 months worth of data from the SuperCam microphone. In total, they found 55 acoustic pops recorded over 2 Martian years, and most occurred during storms or within dust devils. It was looking more and more like this could be the sound of Martian lightning. But are these tiny pops really evidence? Could there be another explanation? In their paper published in Nature in November 2025, Sheed and the team systematically assessed possible alternatives. Perhaps the lightning discharge came from the rover itself, but the sound doesn't match any known rover noises. Maybe a grain of dust hit the microphone or his housing causing the unusual pop, but that can't account for the electrical interference. What else could the team do to test whether what Perseverance recorded really could be lightning? Well, they decided to recreate the conditions of a Martian storm here on Earth. Using a replica of the SuperCam instrument, they generated a static charge by rubbing particles together and then recorded what the microphone detected. The result was incredibly similar to the electromagnetic spike heard by Perseverance. After analyzing all this data, the team concluded that the 55 mysterious pops were best explained by the electrical discharge of lightning on Mars. And that's not all. In February 2026, another team added weight to the argument. While sifting through a decade's worth of data from NASA's Mars Atmosphere and Volatile Evolution, or MAVEN spacecraft, scientists from Charles University in the Czech Republic found one other tiny piece of evidence: a Whistler wave. On Earth, Whistler waves are low-frequency radio signals that travel along the magnetic field lines of our planet's magnetosphere before dispersing. But what's most interesting about them is what creates them. They are a telltale sign and arguably proof of lightning. We've seen them on other planets with both strong magnetic fields and atmospheric electrical discharges, Jupiter, Saturn, and Neptune, but never before on Mars. Why? Well, Mars doesn't have a global magnetosphere like these other planets because the internal activity that creates them stopped billions of years ago. What it does have, however, is localized acoustic fields. These are much stronger in the southern hemisphere than the north. And it's now thought Whistler waves can travel along these field lines when lightning-like activity in dust storms takes place. The question now becomes, is this a common occurrence? So far, out of more than 100,000 MVA data points, the team has only found one Whistler wave in Mars's ionosphere, and it lasted just 0.44 seconds. It's only in very specific conditions that these waves can be created, given the transient nature of Mars's magnetic fields. And MAVEN has to be in exactly the right place at the right time, which is hard, if not impossible, to predict. But just because we don't see it all the time doesn't mean it's not there. This fleeting signal, combined with Perseverance's discoveries, is telling us that there is almost certainly lightning there. Martian lightning may not be powerful bolts like those seen on Earth. It's closer to a static charge, the kind you get when you walk across a carpet in socks and then touch a metal doorknob. But with so many storms and dust devils raging across the surface, it's likely that millions of these tiny static charges occur. And that has big implications for our understanding of Mars. You see, when dust is electrically charged, it's easier for wind to lift it up. And it also alters how the particles clump together. So the lightning isn't just a product of Martian weather. It helps drive the storms themselves. The presence of lightning could also solve a long-standing mystery: the origin of Mars's oxidizing chemicals. Mars is full of highly reactive substances known as oxidants. For decades, scientists have been detecting them in Martian soil and atmosphere, but until now, they couldn't fully explain how they were being produced. These newly discovered electrical discharges may provide the missing mechanism. Even though Martian lightning is far weaker than Earth's, it still carries enough energy to break molecules apart and create new ones, including hydrogen peroxide and perchlorates, both of which are found in abundance on Mars. This has important implications for the search of life because these harsh oxidants rapidly destroy organic molecules, effectively sterilizing the surface. So even if Mars once hosted life, the chemical traces it left behind could have been altered or erased. To have any realistic chance of finding evidence of life on Mars, future missions will need to look below the surface, targeting rocks and sediments that are protected, buried, or shielded from the harsh oxidizing environment on the surface. But that's not all. The discovery also has implications for Perseverance as well as other rovers active on the surface. Because when dust is electrically charged, it becomes clingy. If you've ever accidentally spilled the contents of a beanbag, you'll know how clingy those tiny polyirene beads can be. As the beads collide with each other, they generate a static charge, causing them to cling to your hands, your clothes, the broom, everything. On Mars, electrically charged dust can cling to the surface of the rovers, persistently coating their instruments and solar panels. In December 2022, NASA's Poor Insight lander had accumulated so much dust on its solar panels, it lost power completely and never powered back up again. Thankfully, the next generation of landers are already in the works, with Rosalind Franklin rover currently due to launch in 2028 and ISRO developing the Mars Lander mission, also known as Mangalian 2, which will set off for the Red Planet in 2030. And what's arguably more exciting is the fact that in the future, rovers and landers might not be alone on the surface. Both NASA and SpaceX have ambitious plans to send humans to Mars within the next decade. In fact, SpaceX is planning to send its first starships to the Red Planet at some point in 2026. And that's our Artemis missions to the moon are well underway. Yes, it's not Mars, but their success will be vital for testing technologies needed to send humans further. They will allow scientists to iron out any kinks in setting up long-term settlements and life support systems on a world beyond our planet. But one thing the moon can't help us plan for is dealing with this newfound Martian lightning. Is it something astronauts need to worry about? The good news first: the first human to set foot on Mars is unlikely to be struck down by a bolt of lightning, as it is far too weak. But frequent small electrical discharges could interfere with astronauts' equipment. So, while Martian lightning may not be as impressively powerful as the bolts we get to witness here on Earth, the discovery represents a genuine engineering challenge for future missions. To truly understand Martian lightning, much more research will be needed. But this chance discovery by the Perseverance rover is enough to open up new avenues of research and show that even after decades of close observation, Mars keeps surprising us. Who knows what the rovers will discover next? Patreon members got access to this video ad-free. And more importantly, they keep Astrum grounded in a community passionate about space, not just YouTube AdSense and algorithms. So sign up with the link in the description. Being a member means you're part of the reason Astrum can focus on the kinds of videos people actually want to watch. It's where our most engaged viewers are. People who care about learning, exploring, and seeing what's out there. If that sounds like you, join the Astro Patreon today and be part of where we're headed.